Hello geometry students, I'm covering section 11.3, some extra problems. There were requests about some questions which are not as easy, so I thought of covering them from textbook. These are from textbook. Few problems like example 3 on page 612 from your big Aya textbook, not a student journal, keep in mind, and from exercise section question number 22, 27, 28, that is on 614 to 650 from your hardcover big idea textbook. All right, so let's move to questions one by one. There is a very first question, finding the area of the polygon, example 3, and that is basically they have given you a nonagon. Nonagon means it's supposed to be a 9-sided polygon. It's regular, means all sides are congruent, and it has a radius of 4 units. And find the area of nonagon. You have to find the area. So whenever you're supposed to find the area of any polygon, you're supposed to imagine the triangle lying inside like this. So you just bring that triangle here. You see the triangle is drawn here. So because it's a nonagon, means 9 side, and total circle is how much? 360, and we are interested in finding this angle. So it means all central angles are going to be same. So that's going to be 360 over 9. So that's going to be 360 over 9, that is 40 degrees. So central angle is 40. If that central angle is 40, so let me make this one little bigger here. So if our central angle is 40 here, let me draw it. Suppose just rough sketch. If this whole thing is 40 degree, so this is 20 and this is 20 degree. That you can see here. What else they have given? They have given the radius is 4 unit. Means this is 4 and this is 4. Means this is supposed to be 4 and this is 4. I have so bigger version here, 4 and 4. We have to find the area. So you just have to imagine a triangle like this. Then your work is to somehow, because the area is what your formula is, apothem times perimeter over 2. That's the formula. Apothem is basically you have to find out how much is that. If that is given, good. If that's not given, now your work is to use trig and find. So up to you. You can use any kind of trigonometric ratio, whatever ratio you like to use depending on what is given. So there is no fixed way. Here in this example, they're using sine and cosine because I need to know how long is that, so that I can find the perimeter. Means the side is how long, each side is how long, because it's a regular nonagon, and I have to find the apothem. How long is that? What is the height of this whole thing? That we have to find. So we will be using trig part here. So if I'm taking sine to 20 degrees sine, so remember, so ka toa. So we are using, so sine is opposite over hypotenuse. For sine, here this is 20, this sine 20, so this figure is I'm drawn here, so you can just compare it. So sine 20 O opposite for this is, and hypotenuse is this. We haven't been given this, so just plug it in. So here you get sine 20 is mk over lk. mk over lk. So they have used different names. So they have mk, and this is j, this is l. Sorry, this is l. So instead of this triangle, they're taking this. It's fine. Both are same congruent. So it's fine if I'm just taking this angle. So means our opposite is here and hypotenuse is this one. Opposite over hypotenuse. Just plug it in. You just have hypotenuse given. Just LK is going to be replaced by 4. Now here you cross multiply. Your MK is what? How much? 4 sine 20 degrees. So our, let me write it down here. this is going to be this, only this width is going to be how much? 4 sine 20 degrees. Then if I know this part, I know this is congruent to this, I can easily get my JK. So they have found out the JK is going to be the side length, and that's going to be twice. Just multiply it by that 2, and your answer is 8 sine 20. You can, if you want, you can plug it in sine 20 before, but you can leave it as it is till n. Now you have to find apothem here. For apothem, this is your apothem which you're supposed to find out. So this is the apothem. You have to find how much is the height. Same way, up to you. Use the tangent ratio, use the cosine, sine, whatever you want to, depending on, there is no fixed thing. Up to you, whichever you can apply. So they applied cosine 20. So cosine is what? Ka, adjacent over hypotenuse. So they're taking this one or this one. Up to you. You can take any triangle, right or left. Same calculation would be done. So ka adjacent over, adjacent is this one. For this 20, I don't know, so I just leave it LM. LM is here. Then LK is the hypotenuse, that's 4. They plugged it in here. Now cross multiply, you got LM. LM is what? 4 cosine 20. So we got, this thing is how much? 4 cosine 20. I got my apothem, I got my side, and what's the formula? I just plug it in this one. Now our this is our side, this part is coming from, this is our 4 cosine 20. So that's the apothem, 4 cosine 20. This is your apothem, and this is your side. And how many sides are there? The 9 sides. So perimeter means for this part you will be multiplying by 9. So 9 times 8 sine 20, and you're going to get this was side over 2, sorry, MK, it was not the whole side. So this is the side. Just multiply, you get 46.3 square unit, roughly equal to, that's the area of this nonacon. Let's move to next problem. Here, question number 22, you have been given a polygon and you have to find the area of it. Same way, very first thing, whenever you have to find, you have to imagine a triangle like this forming with one side and the height. Your work is to find how much is that and how much is that, apothem and side, so that you can find perimeter. But it has how many? It's a hexagon, so it means it has 6 sides. You have to find a central angle. How much is that? So the whole round is 360, so it's divided into 6 parts. So that's 360 over 6, that is 60 degree. So you got, this part is how much? This is 60 degree. If this is 60, I can say this is 30 and 30. So I have taken a bigger version here so that you can easily understand. This is 30, 30, and what else they have given? They have given, it's a regular hexagon, so that 7 means every side is going to be 7, 7, 7, here 7. So means this bottom side is also 7. If that is 7, so this is 3.5 and 3.5, half of 7. Now I got side, I need to know the apothem. I need to know how much is this. This height is how much? Apothem. Just look carefully. This is 30. This is 90. How much is this? 60 degree. It's a special triangle. So you look at this picture. There is a relation between sides of special triangle, 30, 60, 90. So angle side opposite to 30 is x. Side opposite to 60 is x root 3, and side opposite to 90 is 2x. We apply the same. So this is x and this is x root 3. Same way, this is 3.5. So this is going to be how much? 3.5 root 3. We got our apothem. We have everything needed here. This is apothem and this is our perimeter. So we plug it in. Apothem is 3.5 root 3. Perimeter, 7 is the side measurement and there's 6. So 6 times 7, that's P, and that's A. Just multiply and solve it, you get 127.31 square units. That's the area of this polygon. Let's move to next question. In exercise 27 to 30, so I'm skipping 30 here, 27 to 29, find the area of shaded region. You have to find the area of shaded region. Means, how can I get this green one when I know the area of the whole circle, and when I know the inside area, when I know this area, I just subtract it. So I get the outside one. How to do it? I need to know how much is the inside one. So let's do that. Let's calculate the inside one. I told you always take the triangle forming with one side and try to find side and try to find apothem, this thing. So I'm just taking it out because let's see how many sides are there. This is 1, 2, 3, 4, 5. 5-sided. It's a pentagon. So pentagon means 360 over 5. Whole circle is 360, so each central angle is going to be 360 over 5 is 72 degrees. So we know that this angle is supposed to be 72 degrees, so it is going to be 36 and this is going to be 36 degrees. So I just drew this circle outside so that you can easily figure out. What else they tell you? Here they tell you the side is 12. This whole thing is 12. Alright. Now I have to have how much is this apothem. Now how to get that apothem? Just look at this triangle on left or right, any triangle. This one angle is given. You can always use the trig ratios. They're using tangent 40-54. They're using tangent 54. How you get tangent 54? If this is 36, so this angle is going to be what? 90 minus 36, that's 54. Up to you. You can use different trigonometric ratio to solve it. Your choice. They're using tangent here. You can use any other here. So you got 54 here. So tangent 54, and for tangent it is TOA, opposite over adjacent. So for this one, for this angle, opposite is this here and adjacent is this. Okay. Now if I know the total is 12, so this is going to be 6, 6. So 6 is the adjacent and opposite is, we don't know, apothem we don't know. So tangent 54 is A over 6 here. Cross multiply is 6 tangent 54 and you get your apothem is roughly equal to 8.3. You have your apothem, you have the whole side, you can easily find the perimeter. Your formula half times A, apothem times. Now perimeter is what? You have to multiply how many sides are there? 5 sides. So this is apothem here, this is A, and this is your perimeter, 5 times 12. Solve it. You get your area for the pentagon. But they don't want you to find the area of pentagon. They want you to find the area of shaded region. So you need to know the area of the whole circle. So for circle, we need to know the radius. Is that given here? We need to know this thing. Is that given? The radius is not given. I have to work for that. Apothem I got this base one. So it's just like a right triangle. I have 2 legs. I can find the hypotenuse. That's going to be r square is what? 8.3 square plus 6 square. Because this is 8.3 and this is 6. This way you can get your radius. This is the radius here. You can get that. You solve it, you get 10.2. When you get your radius, you can easily find the area of a circle. That's pi r squared. How you get this? Area is what? Pi r squared. You applied the area formula of circle. R is 10.2. You solve it. Now you have the area of the circle. You have the area of pentagon. To get that shaded region, you subtract the both areas, and that's your final answer. All right. Let's move to Question number 28. 28 is what here? The quadrilateral. You have given quadrilateral is a square, and you have to find the green area. Same way, get the area of circle, get the area of square, and then subtract it. And it's good that this is a square, so their diagonals are going to be equal. So this is 14, so this is also 14 because they bisect each other. Same way, other diagonal is going to be what? 14 and 14. So the diagonals are actually 28 and 28. And what's the area formula? You can just multiply the diagonals, divide by 2. For this case, that's 392. Area of the square here as a formula of square. Now as a formula of square. So now we need to know the area of circle, that's pi r square. This is actually pi r square. So you get your area of the circle, and then you have the area of circle and square, subtract it, you get the area of the shaded region. Alright, so let's move to other question. Oh yes, we have to do up to 28. I hope you get it. Let me know if you don't get it. So let's move to last problem, 29. Here we have been given a figure, triangle inside a circle, so it means we have to find the area of the triangle here, and we have to find the area of a circle, then subtract it. So what I would do, I would first look at it carefully, and I told you always look at the triangle given here. So you bring this triangle outside and then find the apothem. Apothem is basically this one, and base side. These two things we need to know. So when I know this is a triangle, and here based on that we know that we have to find this central angle, and here how many central angles will be formed? There are three sides are there, so each central angle is going to be 360 over 3, that's 120 degrees. Once it is 120, then I know this is going to be 60 and this is going to be 60, so I have made it outside here. That's 60. This is 90. I know this is 90, so how much is that? 30. So now it's a specific kind of triangle, special triangle, 30, 60, 90. I know shorter leg is x, longer leg is x root 3, and the hypotenuse is 2x. So we compare. We have been given hypotenuse, that is 8. That's actually 2x. So how much is x? X is 4. 4 is here. How much is longer leg? 4 root 3. I have used this formula. So you get your basis. So I know here this is 4 root 3. So it has to be also 4 root 3. And also we know that this length is how much? This is, let me just erase it here. This leg is what? How much? 4. So you use that. So we have apothem. Apothem is 4. Side is 4 root 3. 4 root 3 means total is 8 root 3. So that's the side. Now we have side, we have apothem. Just plug it in. Half of this is apothem is, this is apothem, and this is perimeter. Perimeter is what? How many sides are there? There are 3 sides, and every side is 8 root 3 multiply, and that's your answer for the area of triangle. Now once you get the area of triangle, now you need to know the area of circle. When you look at the circle, this is actually the radius of the circle, so pi r square. That's actually pi r square. So pi 8 square, that's 64 pi. Subtract both of them. Then when you subtract 64 pi minus, you have area of equilateral triangle, that's going to be 8 root 3 minus 40 root 3. What they have done, they have split it over, but you don't need to do. You can directly write down this expression, 64 pi minus 48 root 3. Alright, you can simply do it. I don't know why they just split it over here. You just plug it in your calculator, your answer is going to be this one, and your final answer is that. I hope you get it. If you don't get it, please let me know. Thank you so much. Stay safe.